We are back for another version of this MLOps podcast coffee session. I am here with none other than the co-host of the show, Bam Bam, and a very special guest today, Satish Chandra Gupta. He is here because I somehow stumbled upon his Towards Data Science uh, blog article, and just thought it was incredible. He has some really just amazing insights when it comes to building these big data platforms. And so I immediately reached out to him, asked if he would be interested in coming on here and sharing some of the learnings that he has and talking a bit through this blog post, how he managed to create it and what his insights are around it. So that is a little bit of the background. Now, Satish, maybe we can hear about how you got into this in the beginning, because I know you were coming at it from a software engineering perspective.
Hey, thanks for having me. Yes, so almost all my work life, I have been writing compilers and program analysis tools, dev tools, IDEs, memory managers, and all sorts of things. And I was working at Microsoft Research at that time, and I found a colleague solving a very interesting and very hard program analysis problem using machine learning. So I was kind of taken aback that, whatever I had learned or mastered for 10 years, somebody could just mine data and do at least parts of it, if not fully. So that was kind of an eye opener. And that is how I got hooked into it. And Microsoft Research was a place where it was encouraged to learn whatever you want to learn and try out things. So that is how the interest started. And in later point of time, I moved to building microservices and ML applications. And that is how I got into the data pipeline stuff. I think the most of the things that I wrote in the article I did in 2016. Yeah, 2016, towards the end of 2016. So I mean, it was way earlier than now. Now things have become much better. So that's how I got into building it. And during Microsoft Research, what also happened, which got my attention, was that AlexNet has come out, which so there were earlier machine vision, computer vision applications, and it bettered them by more than 10%. Any known machine vision application. So in research, improving something by 0.5% and 1% is a significant. Beating something by 10% was outstanding. So that is when I first learned about DNNs, deep neural networks, and so that is how it all started. And slowly, over a period of time, I taught myself machine learning, and that's how I got into all this.
So you hit the ground running with the machine learning. You went from Microsoft Research, and you're now at a new company. And I know we're going to get into that in a little bit, but can you give us a background on what you're doing now?
So right now, me and my couple of my friends, we co-founded Slang Labs, where we are building voice assistant as a service, so that programmers can add voice assistants to their application. So it is like Siri inside your app, which understand your app very, very deeply. So if we compare it, let's say, with Google Voice Assistant, if you start something, it will bring up the application and it would leave you there with the deep links. And then your interaction with the application will progress with touch as the normal application. But here it is like, the voice assistant is inside the application and it understands your app and it is specialized for your app. And the whole idea is that programmers don't need to do a lot of things related to NLP and speech recognition. They should get a lot of stuff for free by just defining certain mappings. So that is what we are doing. And I would be happy to talk at a later point.
That sounds really fun. So definitely want to get more into that a little bit later. But one thing I'm curious about, so there's a lot of people focus on different areas in the ML workflow. There's been a lot of attention on the training for some years now. Now deployment's a really big thing, monitoring, right? But one thing that honestly I've had the most challenge, like difficulty with, is actually the data. Like When I worked as a data scientist, most of my challenges were around the data itself. As an ML engineer, building my own data pipelines to get my features. So data has been honestly like the bottleneck in a lot of ways. Like it's like that's where, and honestly, if I mess up at that stage, the model itself is going to be terrible. So why, I know why the data part is particularly important to me, but why were you interested in thinking through a lot of the challenges in that space? Because I think, as you recognize, especially in the article, there are some distinct challenges that come with the data aspect that I think makes it a little bit different from the training components. Now, there's a lot of overlap, and maybe it's not important to fully distinguish them. But why were you interested in this particular part of the workflow?
Yeah, I mean, see, there are two parts of data. One is the data pipeline that get used into the training, right? You pick it from the lake, you transform it, and you extract the feature, you train your model, and then you have to keep repeating it, use versioning and whatnot, right? Uh, so, so that is one part of the data. But how does the data come to the lake at the first place? Many time, at least in the real businesses, you are training or you are using data not just randomly scrapping from the web. You are training it on the data that business or applications are already collecting. So you go to any company, they already have systems which do certain kind of things. They probably have some kind of analytics team. They would have warehouses, data warehouses. So they are already collecting a lot of this data. And if you one of the problems that I don't know whether you have come across or not, but one of the problem is that we call it like, island on the lake. So you have a big lake, you have a humongous amount of data, but all that data is not really useful. You can't use it because you don't trust it. And you would slowly build a small island of the data, which probably is like 5% or 10% of the data. And that is what you would use in your training. But think about it, like how much you are letting go. A lot of people say that, oh, they have data, but then I ask, what is there in the data, like what kind of data it is, and they have no clue. Then it is just bytes. I mean, it is just rotting your storage if you can't tell about what is there in the data. So a lot of hygiene issues are there. And since I come from a software engineering background and not ML background, I think it was very obvious to me looking at it, that how we can make more of this data useful immediately. See, it is not like somebody else is collecting data and we are using it. We are collecting data and we are using it. It is like, as a data scientist, what I would want to do is, it is more like, investigation. I am a detective. I'm trying to find out some insight that can help my business. And the data is the clues that, has been left behind. The only difference is here, criminal is not somebody else. We are ourselves criminal. So as a person who, or as an application who is generating the data, we can kind of assist the data scientist who is going to look at it later point of time. So that is where a lot of my hard battles were fought, like, how to get most of that data that business is collecting to become useful for me to train model, because more data I got, better models I can train. So I think that's why it is slightly different. Now the pipeline does include the feature extraction and those kind of things, but it starts a little bit earlier in a more traditional sense. I mean, if you look at analytics data pipeline, it starts a little bit earlier, and we care about what is being generated and how we can generate better data.
Yeah, one thing I think is super interesting on your article, and by the way, I didn't say it before, but we have links to all of your articles in the description below if anybody wants to check them out. But one of the most highlighted pieces of this towards data science article is the 5 different stages that are grouped into 3 different personas or people's jobs or tasks. And the first one, which is the most highlighted, is the data engineering task or the data engineering persona. And the tasks that they have to do are the collection, the injection, and the preparation. And then you go on to say, like, the analytics or the machine learning head is doing the computation, and then the delivery is the presentation. So potentially like the business person, right? And I just find it fascinating how you're grouping into these positions. Like, all right, this should be owned by the data engineer, and this can be owned by the machine learning engineer. And as you're looking at the data pipeline, do you see much overlap there of that, or is it something you feel like these people are working? I guess they're never going to be working on their own, but can you just go
Yeah.
into this statement a bit more? I
Yeah,
guess is what I'm
yes.
asking.
I mean, these are three different kind of things. That does not necessarily mean that there will be three different people who would be doing. Actually, what I have found in my experience is that most of the innovation happens at the intersections of fields. So, for example, machine learning, data engineering, and software engineering, even business. The person who is able to cross over and at least venture a little bit, if not too far deep, at least a little bit on the other side, they would understand, they would have a much more complete perspective of the circumstances, and they would be able to have the insight about how to go about solving these things. So even though I listed, I mean, that's right, that when I am wearing data engineering engineer's hat, I am like too focused on pipeline, software engineering, and all discipline and rigor that comes with it. And when I'm thinking of data science, then it's more like a statistics training model and those kind of things, and my days would be gone there. But when I am presenting it, then I have to wear a completely different hat. I mean, I cannot go with my rigid silo-ness of data engineer or data science, but think about how it would get used finally, whether it would move the needle for the business. And so that's a slightly different role, and it is happening more and more that people don't live in these silos. They cross over. They might not venture too far. I mean, between data science and business, I think that is never two different people. They always cross over, but I think more and more is happening towards software engineering side, that people cross over the boundary. And I mean, I am coming from a software engineering background, all said and done, right? So yeah, I mean, but in data engineering, what we focus on is the hygiene of the data, the cost of the data. I mean, I don't want to venture into the numbers, but I can tell you, smart data collection can help reduce your pipeline cost by 90%. I mean, this I am telling from my seeing my own bills about how much money was being spent in the data that was coming and processing in the pipeline and storing in a data warehouse. If you do it a little smartly about what you collect, you are thoughtful about what you're collecting rather than collecting everything. You're thoughtful about designing the schema of the data that you would collect. And it does not mean that you have to foresee everything, but a little bit of thought, because you don't know how you would end up using, but little bit of thought about, rather than just dumping everything, whatever you are coming across, but thinking about like how it would be used, for what it could be used, and shaping your data at the collection itself, in like your edge devices or wherever, website, whatever is your where you're collecting data, it's shaping it a little bit can cut down your cost to like 80, 90%. And this I'm telling you from the bills that we saw a month of a big deployment costing $30,000, and we reduced it to $5,000 in the next month. So
that's so
Wow.
interesting. How, yeah, because you would, I guess it's the tendency is to err on the side of
yeah,
collecting everything.
but you have to process. It would require compute. It will require storage. It would require extraction also at a later point of time. All this will cost money. So even if you are collecting everything, you have to be mindful about how you are shaping it, and because those transformations also cost money. So you can be a little bit mindful about what you're collecting and how you are storing, and that can save. I mean, maybe this was extreme case. I mean, it was probably too bad, and that's why the savings were too high. But I suspect, I mean, 25% savings, I mean, I suspect would be there any day. I mean, that is what my gut feels. I don't have a number to prove it, or I study to prove it, but seeing at least 3-4 projects, I can tell that 20-25% is no brainer. Most likely you'll get it.
Honestly, that's incredible. That's very believable. And like, especially seeing how the data is typically treated. Like, yeah, I think Demetrius is right. In my experience, I've seen we err on the side of just kind of collecting everything, but there's costs associated with getting all of that. Like you said, transforming that, storing that. And yeah, I think what you talk about in the article is these different perspectives and how they play a role in data analytics and machine learning pipelines. And you focus mostly on the engineering perspective, and you list these desired characteristics, which seem to also be informing kind of the things you're saying right now around accessibility, scalability, efficiency, monitoring, right? All of these things are important. Why, I guess maybe we could talk about the relationship between these engineering characteristics and how they relate to data, because I do think you can apply some of these, best practices from engineering, and think about them and, through that lens.
I mean, I did not quite understand what are you asking?
No, sorry, let me repeat. So basically, you talk about these engineering characteristics of a data pipeline. I just wanted to talk a little bit more about some of those characteristics: accessibility, scalability, efficiency, monitoring from the perspective of an engineer, because there's multiple.
Sure. Yeah, right. I understood now. Yeah. So by accessibility, I mean that if you have collected the data, how quickly it is accessible. Like, do I have to wait for half an hour or 3 hours? And I basically I will submit a job which will run a map reduce and then scrap parts of the data, and I'll get to see, and then I'll find out, okay, I need to do something else. I mean, how quickly it is available to data scientists to consume it, experiment it. That is the accessibility part of it, and it boils down to basically two things. First of all, how organized your data is, that and whether you have cataloged it. So do I have to look at it and figure it out, or I have to go and see the code which generated this data, or I have to talk to an engineer to find out what it is, or I can look at the data and the catalog and just know that what this data is, right? So that is and how fast it is accessible. Can I write a small query? Is it live? Can I just give a time slice and get it very quickly? And what is accessibility? I mean, so that is a accessibility design by design. The scalability is how much data you are collecting and how soon it becomes available. So, for example, at one project where I worked, there were this. It was a what do you call taxi aggregator company where every cab was generating a beacon every 5 seconds. And if you look at, let's say, just a small diagram, just to give the context, if you look at e-commerce company, they are constrained by demand. They have enough supply. Their problem is how to find out buyers. But if you look at, let's say, Ubers and these kind of companies, they are supply constrained business. They are not constrained by demand. If they have double the supply, there will be double the customer. So every time a cab is vacant, they are losing money. So the whole idea is how you can increase the occupancy of your cab most of the time by either shaping the supply or shaping the demand. So every cab is generating every 5 seconds, they are generating a beacon, and within 30 seconds I have to find out if I can nudge some user by whatever data mining and the model I have made based on, let's say, their lat long and their time of the day, week of the day, location, and whatnot, that they are most likely going to take cab in next 15 minutes. Can I pull them? Can I advance them by another 15 minutes by just pinging them? And all this decision has to happen in 30 seconds. So you understand the scalability. They're not. So we were getting like a billion events every day. So on a 3-node cluster, because you can't increase cost arbitrarily. So in 3-node cluster, how you can scale this kind of massive data pipeline and how to manage that. And that is where then efficiency comes, and then monitoring comes, that I made it work and it is working now. How do I know that it's continue working? Whether I would someday wake up and check and find out, oh, it did not run for last 3 days and the model is stale, or I would get an alert saying that, your model is something has gone wrong. You look it here. I mean, these were very initial days. Things now are much better than how they were in 2017 and 16. So a lot of these things have improved a lot. But yes, so monitoring is that aspect, that how you, instead of you discovering or keep looking, how can you be, you could, the alert should be pushed to you rather than you going and pulling and looking what is going on in the pipeline.
Yeah, I think that's a great point too, that I remember Shubi Jain told us about way back in one of the first episodes, about how when he's monitoring 3 different pieces of the puzzle. He's monitoring the data and the health of the data and making sure that he's actually getting the data. and then he's also monitoring the system to make sure that everything is all right, like the traditional software engineering monitoring, and then he's monitoring the model. And so you have that like trifecta, and what you touched on right there is so important too, is like you have to make sure that you're getting the data, like monitoring the data is a huge piece of that puzzle. And so I find that part fascinating. I love talking about monitoring, but I know there's a ton more that we wanted to get into. And before we move any further ahead, I wanted to ask you about tips for cost saving when you're building this pipeline, because like you said, oh yeah, maybe anybody can get like a 25% reduction in costs. What are some things that you found will help in that besides just knowing the right data to be picking?
Yeah, so I can.
Yeah, go ahead.
So see, as a program, so if you look at it, who is collecting the data? The data is being collected by the person who is writing the application. Traditionally, if you see, I'm pretty old, even though. So we write our application thinking about control flow. It is like very procedural that you get this, you check this, then you take a if or you do a loop. That is how we think when we are writing code. But if you look at data analytics or machine learning or data science, it is more about data flow. That what was the data and then what it became, and based on these two events, how you can correlate and infer an insight, right? So the programmers are very control flow oriented, but the data science is very much data flow oriented. Now, when people are dumping data in their control flow way of thinking, as a data scientist, what we have to do is we have to kind of replay their control flow, or at least understand their control flow and somehow turn into data flow. So I think that is a hard part. Like as things happen in the program, they keep dumping bits and pieces of data. Instead of that, what is required is that the tweak that was required most of the time is that you think about what data means in totality. Can I use this data to gain any meaningful insight? I mean, you don't foresee what need would be, but can I hold on to this data for some more time? Let this thing complete, and then I will send this whole data together. So I call it something called sentinel state. So in your program, instead of dumping data as and when you are having and as and when you are wanting, you think about the sentinel states in your program, and you dump data so that it can be correlated easily. And that is where the compute saving comes and the storage saving comes. So I mean, I can probably write an article on it, but that is the fundamental difference, that you have a control flow, but you jot down the data flow aspect of your application, define some key state that are sentinel states, and then you would be able to think that, okay, this is a data which is kind of semantically complete, and you dump those data at those sentinel states, and then it becomes much lesser compute actually cuts down a lot, and storage also actually it cuts down significantly. And this cost is happening at the edge, so you don't pay as a company, like the person who is running the mobile phone, he's paying that cost, and he would be anyway paying that cost, right? The program is running, so the cost getting transferred and distributed across devices rather than your pipeline. So that's how you can save some of the money.
Man, you said so many good things there, guys. For our listeners, I would encourage you to read the article because he is mentioning a lot of these things there, and read some of his other writings. But I think you said some really great things. I want to talk about data pipelines now, as it's the kind of the central thing that we're talking about, right? These data pipelines. I want to talk about some of the different, I guess, the components of that, right? There's the engineering that's involved to collect it, to ingest it, to prepare it. You state in your article, most of the effort there, around like 50% of the effort, definitely true. Then you got to do your cool stuff on it. You need to do your computation, some analytics, your machine learning, right? You develop the applications to learn from that data, to leverage it. 25% of the effort, which is typically true, right? The training code is usually small. And then you got to deliver it, right? There's some way that it has to reach the end users, right? And it could be something as simple as a report, right? Like analytics is reporting things, building dashboards, or it could be a prediction service that is making the model readily available. So I want to talk about some of the different aspects of that. We could start with collection, but yeah, I would love to talk more about that.
Yeah. So the first first point of engagement is collection. That is where the action is happening. That is where the user is. So whatever user is doing, whatever you are interested in, that is what the collection is. So, and collection can be extremely diverse. It could be your browser, it could be IoT devices, it could be mobile phones, it could be all sorts of things. I mean, it could be other, let's say, your events that are happening in other microservices. They can also generate the data that you would need to use it in data science. So the collection could be, and actually it is the most diverse piece. What is needed is that you have to kind of maintain the schema and the catalog so that it comes together nicely. So in the sense that at the later point, so for example, look at our SDK. We collect data from Android SDK. We collect data from, we have a WebOS SDK also for voice assistant. And these two are a very different platform, but the kind of data they generate, we have found out a way so that the schema is pretty similar. I mean, it's not exactly same, but you kind of come up with a schema that the data would get generated. And then this data goes, I mean, there are different ways that can be ingested. There are two most common ways. One is MQTT, which is used for most of the IoT applications because you need a very lightweight protocol. And then there is a REST HTTP endpoint where you would dump the data. For example, let's say I'm using a PubSub, Google PubSub, and it would be exposing a REST endpoint, and it could be dumped on it, or there could be a cloud function, or there could be a web service that gets the data and just dumped into the PubSub queue. So that is the collection point of it. Now, once it reaches to PubSub, that is when the ingestion is starting. Right now, the data has come to the company's infrastructure, company's network. I mean, whatever your project's network, and there could be from there on. There are two types of data. One is streaming data, and one is kind of a batch data. Batch data could be like the other modes of legacy system that are generating data in some buckets or some other RDBMS and things like that. So there are two kinds of data that you got. You got streaming, that is event as it is happening. So for example, that cab company I was talking about, that was streaming data. And I have to take action within 30 seconds when I start seeing an empty cab. And then there is this batch data. Now, the whole idea behind this pipeline is that you figure out what is a critical need that has to be served in real time and what is a need that can be served, let's say, with latency. Because anything that you want to serve in real time and the amount of data is used, it would cost you money. So you have to very carefully decide that so for example, 30-second decision, yes, I have to do it now. Reporting, maybe it can wait for a day, right? PubSub can hold data for 7 days. I can run a Spark job at the night and it can process in a much cheaper way and things like that. But I mean, empty cab for 1 day would be awful, right? So you have to very carefully decide that what need has to be served in real time and what need can have latency and how much latency is acceptable, right? So that is when the computation comes into the play. You design your computation. So that is where the Lambda architecture comes into the play. What Lambda architecture does is that it says that, okay, any real-time need goes through the real-time pipeline and served real-time. And it will do only part of the data science. And then there will be a batch processing that will come in and augment whatever you have already computed and put it in. And then you would have, let's say, with certain latency, you would have everything. So that is where also you can save money. You can figure out, you can be very precise about what you need in real time and what you don't need in real time. So that is the computation part. Then comes the presentation. Now, presentation happen in 3 different ways. One is the reports that you talked about, right? The business guy coming every morning and saying, okay, how did Bangalore do yesterday? Or how was the business in Chennai, right? How many percentage of cabs went empty? Those kind of things. And they would look probably, once a day kind of thing. Sometime a business could be looking at, let's say today there was a severe rain in Bangalore and there were the roads were flooded. And then you want to find out what are the hot spots where the demand is huge, but supply is not there, right? So there could be a situation where you want to look at the heat map and figure out what to do at those circumstances. So, these things have to be carefully thought about. So one is a real-time need, one is a reporting need, and there is something in between also. So it might not be a static report going to somebody's mailbox. It could be that somebody could come to your portal and access the data science reports or the real insights from your microservices service. So these are the three modes, and actually it is pretty tricky to do it all three in a nice way. Now there is a fourth one which is not very common, which I had to do. It was, I had to send a nudge to a passenger, potential customer, that a cab is available. Would you like to take it? Here is the button. You click it, it would be booked right away, right? So we typically look at the consumer as a business people, but even your customer could be. So even the output is streaming. So input stream is coming out of all these events from the cabs, and output is also like one of the output is a push notification that is going in real time to a customer, and then it decides whether he or she wants to take it or doesn't want to take it. So these are the four ways of you can have presentation. The last one is not so common, but I have seen it. I mean, fraud detection, all these real-time needs would be having that kind of streaming output as well.
Man, that's a lot. I love that. There's so many great things. Yeah, well, it sounds like you have a ton of experience in this area. Now I want to talk about the possibilities, right? It sounds like there's a lot of different ways you could stitch together your big data architecture. And that word big data could, I would say that could also apply to maybe a company that's starting off as a smaller data set. But in general, when you're building this architecture to manage all of this data, you have a lot of choices on the cloud, right? Can we talk about how you navigate that space? You've kind of been getting at it there, right? With first identifying the requirements and the needs, and then you think about, all right, what tooling do I need? But let's dive a little bit deeper into the possibilities of the big data architecture.
See, I mean, this is very interesting actually. And if you look at the history, the data warehouse is not something new. It has existed for like 25 years. And it is started 25, probably more. I mean, Jim Gray was probably the first person who talked about the data warehouse. Definitely 90s. So more than 20 years. So the whole idea was that there was so much data at that time was being collected and was living in silo, how you can bring it all together in a central warehouse so that different businesses can accept and use that data in the way they want to use, right? And it went on. Now then suddenly there was an explosion of data, that when big data came, like there was just so much of data, and it was not only structured data, it was like semi-structured data, it was unstructured data, it was all sorts of data. And where this RDBMS kind of architecture kind of broke down. You can't have, I mean, at that time, definitely, I mean, now BigQuery and Redshift are changing their landscape again. But at that time, you just cannot keep that kind of data. You have to have it in blobs or that kind of storage. So that is when that data lake concept came, that you accept and store the raw data the way it comes, and then you process it as and when you need. Now, the consequence of that laziness, I call it, was that so once you have lake and you have no structure, you can dump whatever you want. And very soon these lakes became very polluted and unuseful. That is when this, people started joking that you have island on the lake that actually is useful. So, I mean, this went on, but there was no solution. I mean, what you're going to do, you can't keep it in RDBMS. You need to have it, and you can't force people to do certain things in certain way all the time. So this would happen. So you would have to have tools to maintain the data quality, figure out all those things, automate all those things. Now, what I started seeing in 2018 with BigQuery, Google BigQuery, that in my mind changed the landscape. If you look at the BigQuery's pricing, they don't charge you much for storage, right? And they charge you only for compute, and that too is a serverless. Let's say Redshift, you still run it all the time. But BigQuery, the compute is only when you run a query. And even there are tons of optimizations that are available. So that is one thing that they had a very, okay, so let me just step back. I think I missed one part. So when all this lake and all these things came, how the analytics was surviving at least was, there was something called OLAP cubes. So people would systematically, methodically build that online analytics processing cube as the data came, so that the analytics queries can happen fast, right? And that was the way of doing it, I think I would say till 2017. BigQuery came suddenly, says that, okay, storage is cheap, and even your OLAP queries, I can do it in like, few seconds. So it is still not as fast as OLAP. Now, actually, it is even faster. So you can do it in few seconds, and it is acceptable latencies for business guys. few seconds, or even I would say 30 seconds is not a bad, that you click and 30 seconds later the report comes to your mailbox is not so bad, or even 1 minute, 5 minutes is not so bad. So they were okay with it, and it opened up a different kind of pricing point. So if you understand SQL, there is something called materialized view, where you can part compute things as they happen so that you don't have to compute again and again. So if you layer your data in a table and materialized views and views carefully, then you almost get the OLAP queue. And the another tweak that came was that these RDBMs became a bit flexible. So, for example, you could have a column that is string and it is storing JSON, and you could do a query of a JSON field. You can write SQL. So, for example, in BigQuery, you can have semi-structured data in the table, quote unquote table, and you could query parts of the JSON. So it is like almost like you can vary if you're designing your schema smartly. Then the unstructured part or semi-structured part, you can keep it in certain columns where you can't index them, but you can carefully query them. So the difference between data lake and data warehouse started kind of diminishing. That is how I see it. I mean, I don't know. I mean, people would probably have a different opinion. The difference between data lake is that it is cheap, but the compute is slow. A data warehouse is that it is rigid and it is fast, but it could cost. Now these two are kind of merging, that you could have let's say Delta Lake. I mean, what is Databricks Delta Lake? So all these hybrid architectures are emerging in data warehousing, where part of the data is in the lake, part of the data is in warehouse, and you put a Hive layer on top of data lake to make it kind of SQL-ish, kind of a SQL queries, and then you uh, present a unified interface over all your data. And the way you decide what to keep in lake and what to warehouses, how much of that data you would need in real time for what purpose, so that you can control the cost. You need something for real time, keep it handy hot. Something you don't need very often and you don't need in real time, you could reduce the cost by keeping it lake, but maintain this catalog. Let's say, one day it could happen that you need that data in a hot space, in a hot way. So then you would have to move it to warehouse, right? So there are a lot of things that are happening. Even now, I think even the ETL is changing to ELT, and it is very exciting. I mean, maybe data scientist guys don't feel very excited, but the software engineers guys, man, you can save a lot of money by just very smartly designing your schema and data storage architecture, and without compromising on the speed or usability. So that's pretty interesting challenge to me.
Yeah. I love your passion for this. It definitely shows, and in the way you write as well. I really appreciate that. One thing I just want to highlight, you mentioned a couple times the benefits of creating a good schema. Can we talk a little bit about that? I feel like that's, and the next thing I wanted to get into is that in the article you give some tips for productionization or at the production stage. But is that one? Maybe we just talk about that on the side about developing a good schema. Why is that so beneficial, and why does that help you save money?
See, if first of all, it may not always be possible to have the schema for each and everything in your system. But if you use that as an excuse to not do it for anything, right? I think that is where you end up spending money. A little bit of foresight of thinking how this data will be used. What I mean by that is actually very specific. See, stats are just stats. In my opinion, statistics are interesting. Like, you tell me how many people yesterday signed up. Yeah, it is interesting. But what I'm going to do with it to make a change in my business? What is the lever that I have to control and improve my business? And so you have to give me actionable insight, that you have to tell me something. So it has to start the other way around. It does not start from the data. What it starts is, okay, what is my business? What are my typical business goals? Tomorrow it could change, but it does not mean that today I be lazy about thinking what are my business goals today, right? So what are my business goals? And then what are the levers I have to affect? Okay, I should put the taxis at this part of the town. That is more beneficial. Or I should stock inventory for cloths, or rather than let's say electronics, because that is what is selling at this point of year more, right? So you have to, the data science has to give me actionable insight that, okay, what I'm to do. For that, you have to understand the business as well as the lever that business has. It may not be always possible. You say that, change the size of the day to 48 hours. It can't happen, right? So you have to understand that what are the practical levers available to the business to move. Now the goal of the data science is to tell what lever to move and how much to move. Now if you do this exercise, it becomes very clear like what data is critical today. I mean, tomorrow it could be different, but what data is really critical today. And so if you pay a bit of attention to that, then you would be clear like in what format you have to collect, how it would get processed to result into some kind of actionable insight. And if you're, it's not the only data that you would collect, but it is the data that you would collect today and use today. And as I said in the very beginning, that data science is not always you scrap the data from historical or from the web. It is also you have to use the data that is being generated today by the business to take the action that will change the business, right? So once you do this exercise, like what are the levers, what I want to change, what is my goal, and then what data I need, the schema of the data manifests itself. And then there are simple database techniques about when you want to normalize, when you don't want to normalize, whether it is going to be a hot data or whether it is going to be cold data, whether you have to serve it in real time, where you can have some luxury, where where you should save money, where you should not save money, become rigid, and that helps. I will give you one very practical experience that I remember. So when I built this system that I was talking about, that I have to ping the customer saying that, okay, boss, your cab is available, would you want to take? And I did all this fancy model collection and everything. And then I ran a dry run for Bangalore. And what I found that there were different kind of cab categories. Only one kind of cab categories were being triggered. So I thought something is wrong with the model that I have built, right? I was building it on a database and I spent like 3 days just to try to figure out what is wrong. And finally, somebody came from some other team who told that, you know what, this stream that you're using, this part of the data is actually not right. We don't fill it. There is another stream where the same data comes and you have to use from there. So when I'm using the curated data, my model is working perfectly. But when in the real world, when I am like running a dry run on the live traffic, I see a very different result. And then I found there is another such stream. There is another. So there are like 3 streams, and I have to collate them, merge them, and use them. And you think about it. Every data scientist is going through it. Why he is going through it or she is going through it? Because nobody has paid attention to this schema thing that I talked about. Thinking about what needs to be collected, where it is coming, so that as a data scientist, I don't want to have these surprises. I don't want to spend 3 days thinking that my model is buggy, right? It's much better to have the data hygiene in place so that people are more effective and more productive, right? So, and then slowly things change in the company. I mean, they came up with the schema. You can't just dump anything. PubSub will start rejecting the data that is coming, and then you'll get an alert. So you have to define the schema upfront. So those disciplines came because of these experiences. And I think coming from compiler background and the software engineering background, I think I understand probably the whole notion of semantics of the data. Maybe I pay more importance to the semantics of data, and that's why I talked about the schema so often. In the company, actually, they joke about it. In my current company, they joke about it.
You're the schema guy.
I'm the schema guy. I'm the data model guy. You have to define the data model. You have to tell how you will use this data. And then is it the right way to structure it? And people don't always like it, but then they see the cost saving. I think there it pays off. It is not fancy. It is not attractive. It is not sexy. But I think it pays. It saves money.
Man, it's so easy to understand you. You have a way of just telling these stories that make it really, really understandable. And I'm taking notes so that when I need to get across these complicated points, it's just
I feel like I'm learning a lot. I'm just like learning. But this is really great. Sorry, go ahead. I didn't mean to interrupt you, Mitch.
Well, I unless you want to jump in on any follow-up questions, bam. I wanted to hear about your learnings with your current project, and you're doing this voice assistant as a service. And I know that we were talking before we started recording about different learnings that you had and different things that you didn't even think through, and then you realize later, oh yeah, we have to do that. So can you go into that a little bit?
Yeah. I mean, it's like very exciting. So when we started this company in 2000, mid 2017, July 2017, uh, we wanted to do something which is very specific for India, and we realized that what is happening is there is a very clear divide. People who are English savvy and tech savvy, they use internet for all sorts of benefits. But people who are not English savvy or let's say tech savvy, they use internet as an entertainment. So for them, internet is Facebook, WhatsApp, YouTube, and just But as a they could use it for banking, they could use it for education, they could use it for so many things, right? And the interface. See, for us, when we look at a computer screen and we see a button, but they don't see a button. They see a box which is colored and something is written on it. They don't know that they can click it. So, we ran some very interesting experiments that I don't want to get into right now because, so we wanted to build something. So we thought, okay, and in India has like 22 official languages. There are like tons of other languages, but just official languages, there are 22 official languages. So what if, and we saw our parents and kids dealing with Alexa and Google Assistant and how they were, I know YouTube had come up with voice search and how suddenly Malayalam songs or Hindi songs or Tamil songs, you don't have to figure out what is a transliterated spelling somebody would have used for the title of the song. You could just speak and search. And we saw how people who don't know English took to it, even people who are not tech savvy, how they took it to it. And that is where the motivation came. So, okay, we thought, okay, let's see if we can, what it would take to add voice to an application. And India, we are app centric ecosystem. We're like very rich app ecosystem. So we took a couple of apps and we tried to add voice to application. And we figured out it is damn hard for a programmer, even for people who understand things. Because you think about it, a very general way of putting an application, it is a workflow, right? Now, at every workflow is what? There are certain states and then there are certain edges where the action happens. The events change the state in the workflow. Now, for every of those transition, if the voice comes into play, programmer has to capture the voice, do the NLP, then figure out, oh, you know what? You did not tell me, let's say I'm a travel app that I want to go to Mumbai tomorrow. Oh, you didn't tell tomorrow, so I don't know the date. I don't know the time. So you have to prompt. A lot of things have to be written. So the business logic gets totally fragmented. If you put all these logic in all interactions, it becomes pretty hard. Even for good programmers like us, we found it very hard. So that is when the idea of building SDK started. So we built a platform that what you do is your application already has bunch of functions. For example, book flight would be a function somewhere in your program. So you kind of give us a mapping between the intent and the booking flight. If the intent is booking flight, then here is a function that you have to call, and we will collect all the entities and relevant information that is needed to make that call, and then we will pass on control. The SDK will pass on the control to your function, and that function can progress. So we thought, okay, wow, this simplifies. Your control flow is your workflow is completely safe. It is not muddled with us. You just give us a table which maps. Wonderful, awesome, very excited. We went. I mean, we took around 6 months to a year to iterating over it, and then we went to the market. What we found that for us, the concept of intent and entity and NLP and speech recognition is so awesome, and we understand it so well. The average programmer, mobile web application developer does not understand in that way. And so that was an eye-opener for us, that we realized that even though we thought we have simplified it, and we had, I mean, if we were programming before SDK and we were programming after SDK, the life was 20x simpler, but it was not simple enough for the people whom we are targeting, the users we are targeting. And these users are programmer, they are not business people, they are tech savvy people. The average programmer, application programmer, does not today understand all kind of things in NLP and things like that. So we have to come back to the drawing board, and we have to start thinking again and put ourselves in their shoes. What would I want? Really drop in SDK if I want. What would I expect? And you have to train this NLP. Like, you have to look at, let's say you are a grocery application, you have to go through all sorts of grocery, articles. You have to figure out how different people will pronounce, what could be different spellings that could be there. And there's a lot of work that is needed, which we did not foresee it in our first iteration when we were thinking, oh, we have to build a platform where anybody could come, create a schema of NLP, and just give the function mapping, and he's all set, and the application will just work, right? And so that is one learning that I had, that we had, that we have to kind of make a special SDK or domain specific drop-in SDKs. That is where the concept came, that voice assistant as a service, that it is a service. So if you want voice assistant for pharmaceutical, here it is. You use this. If you want it for grocery, here it is. If you want for travel, here it is. So we have to take away the pain of of training the NLP and all sorts of things out of the hands of the average programmer, and do ourselves to make it easy for it to happen. So that was a very, very interesting learning, and like how the tech background can blind us from reality. I don't know whether I'm able to express it or not, but it happens more often than we think.
I think so, honestly, and I've seen that myself. Like I work with lots of brilliant people, but there's just so much in machine learning and in this space that it's sometimes it's easy to assume that everyone kind of understands all that, but it's just too big. So even practitioners who are well studied, right? They're still learning new things, new techniques. It's always changing, and I think that that's like one thing that came to mind. Another one is developing like the right abstractions or the right interfaces from like an engineering point of view for the actual users. I think, it's like, it's very easy to miss the point, when you're building, and it may make sense to you as a developer, right? But for the actual users of that, it's, you have to kind of cater to that. And if you don't start with that in mind, you could waste a lot of time, wait, and probably have a lot of pain, actually interacting with it. But that was great.
Yeah. Another thing that, can I just go ahead? I think one more point that I want to make. See, as a technical guys, I think we are very biased toward technology. We feel very, it's natural, right? I mean, that's why you're working, right?
Yeah, exactly.
And we do not, it doesn't come, I should not say do not, but it doesn't come naturally to us to pay attention to user interaction. So one example I can give is, let's say you have a voice app. See, before, let's say your mobile iPhone came, there was no concept of swipe up, swipe right, hold and press and hold. These kind of primitives in the user interface got developed when the touch interface came. Voice is too new. Even if you do everything, how ultimately to build a voice application is still a very hard problem, because there are no reference to look at. There are no primitives to look at what kind of interface you need to make. And that is also became, and voice is a very open interface. So if you give a freedom, like, somebody present can say anything they want. I mean, that is what we see in Alexa and Siri, all sorts of conversation happening. But when you are inside an application, you really want to help the user. At that time, it becomes very critical to design user interface thoughtfully. For example, instead of saying, hello, how are you, what do you want to do? It's a very open-ended question. You say that, hey, where do you want to go today? Can I book a flight for you? You prompting meaningfully so that the user has an idea what she has to say. That helps. Similarly, if somebody fails in saying something, you don't understand what is the intention behind, or what is the intent and parts of the entity. Again, how you prompt it, how you reply to it, what statement you give. That design is also an art that we are learning hard way, because there is nothing existing today to look and figure out, okay, this is how you have to do it. And that can make or break an application. People saying random things and you not serving them, they will say, oh, this is all bogus, it doesn't work, let me go back to touch. You lost them probably for very long time. But if you carefully design the interaction, then they will say, oh, wow, it works actually. And they would use it more and more. And then you would also get to learn how they are using it and making it better. So user interaction and putting yourself in the shoe of the user, your end user as well as programmer, I think those are some interesting learning that we had in this startup.
Yeah, I really appreciate that. Sorry, I just wanted to just point that out. As I learned that as a teacher, that I could understand something incredibly well, but I have to put myself in like the shoes of the student. How would they understand it? What makes sense to them? And I learned that I failed so many times as a teacher, just as a little side note, have building these elaborate lessons that I think are awesome. And then the kids are just like, what, where are you going with this? And I've also seen that as a machine learning engineer. I'll develop some system, something, but I'm not thinking, how it's actually going to be received, who's going to be on the other end of that. And I've definitely made some mistakes, going there. So I really appreciate you giving us that, that learning that you also learned in this really difficult space, right? Voice assistance is hard. It's still a new thing. And then you mentioned it, making it as a service, so it's even harder. But I think, this has been a really excellent session. I've learned a lot, Demetrius. I'm sure you have as well.
So good. Thank you so much for coming on here.
Hey, thanks for having me. I enjoyed talking to you guys. So and your past episodes.
Yeah, I know. He said he's been an avid fan for the last week. He's been checking out all of our other episodes. But if anyone wants to continue the conversation with you, what's the best way? I know you said you just jumped on our Slack, but also, do you use any other social networks?
I think the best place is Twitter. My Twitter handle is SC Gupta, SCGUPTA, my first initials of the first name and then the last name. That's a best place to contact. And our website is slanglabs.in. You can check out what voice assistants we are making and what we're doing. And we would love to hear from you, your feedback, insights, learning. I mean, we are very new and it is always interesting to hear a very different perspective. And that helps us in making what we are making better.
Awesome. Yeah, this was a home run, man. This was really informational, educational. I'm so thankful that you came on here and you spoke with us. You gave us your insights of all of this experience, and hopefully we won't have to go through these pains that you went through. We just take your word for it and we move on and go to the next one.
That's the point. I mean, I have learned from other people's mistake, other people's insight, wisdom, and whatever little I know, I'm very happy to share.
Awesome. Well, yeah, I think that we're good. That'll wrap it up for today's session, and we will see you next time.
Yep. Bye.
Thank you, guys. Bye.